Welcome, my dear students, to the practical part of chapter 8, the mathematical part of chapter 8. And uh, and it's very easy, and it will be like it won't take too much effort from you guys to understand it. And it will come like equation, and you'll just substitute. That's it. Measuring logistic performance, and this is, I believe, slide page 31 on chapter 8. Uh, So the law is the percentage of perfect orders equals 100%. Of course, 100% because you want to get it in percentage. So, so total orders minus orders with defects, which is more than one, by total orders back. Let us go to example directly. Let's go to example directly. I didn't share the screen. I hope that I didn't share the screen. I shared the screen. Okay. Okay. Here is the example back. Here is the law. Shall bring back the law of it. So percentage of perfect orders equals 100% multiplied by total orders minus orders with more than one divided by the total orders back. So it's divided by the total orders back. So here we go. Last year, Bartley Company experienced the following results: 5 point more million orders processed. So they have 5.4 million orders. 300 orders delivered late. This is late. And 25 incomplete. And 25 are damaged. 20 thousand orders billed incorrectly. So when you come to collect all of them, 30 and 50, 80 and 20, this is 100,000. These 100,000, which is collect of all these failures, were spread across 90,000 orders. Okay, so those failures are out of 9,000 order, 90,000 orders. So here, when we get the percentage of perfect, now first we'll see the failure. How much is the failure? Let me go and stop share so you can see, and let us solve it. So here we have a good example of the of how we will collect and calculate the part, which is he's saying all the orders were 5.4 million. All orders were 5.4 million. All orders, total orders, were 5.4 million. Great. Okay. Those are the total orders. Okay. The failure is failure. We will count the failure alone. So the failure is saying 30,000 delivered late. 30,000 plus. Also in the failure, 25,000 orders incomplete. 25,000 orders incomplete plus. There was also 25 damage. 25,000 damage plus 20,000 billed incorrectly. 20,000 billed incorrectly. So when you calculate this 30,000 and 50, this is 80 and 20, this is 100,000 orders equals 100,000 orders failure orders. Okay, those are 100,000 failure orders. He said, out of them, this in the example, this all are data there, spread across 90,000 orders. So these 100,000 failures were spread across 90,000 orders. So those from out of 90,000 orders. That means that this is the number which will take and put in the equation. How about the equation itself? The percentage of perfect orders. So perfect orders mean all the orders minus the failure. So orders, the perfect orders percentage equals all orders minus failure divided by the all orders. In simply, so this will equal 5.4 million. 5.4 million means 5,400,000 divided by, but we will cut out here the 90,000 which were failure. Then again the number back 5,400,000. Of course, this is in 100% multiplied by 100%. This will give you the percentage of 98.3 orders. 98.3% orders. This means what? 98.3% orders were correct, were right, in the right spot or on the right place. Now let me share the screen back. To show again on the paper, not on the board. We'll see it on the paper, not on the board. Share the screen. Here we go. So all are 5.4 million orders. Those are the spoiled, the failure, 30,000, 25,000, 25,000, 20. So 30 plus 50, 25 plus 25 plus 20, all are 100,000 orders. Out of them, 90,000 orders. So the real number of the failure is 90,000 because he said like this, were spread across 90,000 orders. Okay. So to get the perfect ones, all the orders, 5,400,000 orders, minus the failure orders, 90,000, divided by the same, which is all orders, 5,400,000, and this is multiplied in 100%, it will give you 98.3%. So this is the first point. Now we'll go to the second example here, and both of them are very important in this chapter, chapter 8. It's about the location of the place which you will work in. Let me tell you something about this. Let me tell you something about this. The location of the site for the supplier or for the vendor is very important in logistics. Where is the location of the site? As example, I have 3 warehouses. There is a warehouse here, and there is a warehouse here, and there is a warehouse here. But I just want to see how can I substitute all of them with only one, which will be centered in between them. Those, because every point has its dimensions x and y, x and y, x and y, and that's what I will use. What is the x and what is the y? X is the horizon, is the horizontal point, and y is the vertical. Because as you know, every point has vertical axis, and horizontal axis. Every point in math. So we will have 3 points as example. If there's 3 locations, we'll have substitute them like what we'll see now in the equilibrium, okay? But I'm telling you the idea of the example depend on each point in the whole world has vertical location and has horizontal locations. And we are working on both the locations. Come, let's check out here the example. Then let's go from there. Let's go from there. Like here you see logistic decisions models, weighted centers of gravity methods. A logistic decisions modeling technique that attempts to identify the best location for a single warehouse, store, or a plant given multiple dimensions, points that differ in location and importance. Okay, so as example, like you see here, we'll have y, the one which the coordinate one, will be wi by w, and x the same thing. Okay, let's see here as example. Um, yeah, this one is very nice. Ruby would like this example on slide 39. Ruby would like to locate the warehouse to minimize. Locate the warehouse, a one warehouse, to minimize the transportation cost because he's having more than one site or warehouse. He want to put one for to replace all of them. Cost and provide the best overall delivery speed to his markets. At the same time, it should be in the center, in between the three, like I showed you these 3 points. So which one I will get and which one I will put? Okay. We'll take the numbers which we gave me. Like he will give me as example 3 numbers. Okay. And I will take them. Here is the capital city, 400 pop. And Springfield, 200,000 pop. And Cherryville, 170,000 pop. Okay. So this is the places which it is in already. Okay. Now I will take the axis of x and multiply it by these numbers. Okay. I have 400 by 1. Okay. And 200 by 4. And 170 by 4. Let's see. Let's see this. This is another example. Okay. So these are the locations here. All I will do is take the number, multiply by the x, okay? Then check out the numbers. 400 by 1, because 1 here, x is 1 and y is 5. Leave y now, and let's work on x. 200 plus 200 by 4 and a half plus 170 by 4. Let's see here. 400 by 1, 200 by 4 and a half plus 170 by 4. Look, 170 by 4. 200 by 4 and a half and 400 by 1. Okay, this is will be multiplied by 770. What are the 770? Which are 400 plus 200 plus 170. This will give me 770. When I multiply and finish, this will be the 0.2.57. So the proposed location for the point x will be 2.57. Will be 2.57. This is the proposed location for x. Same thing will do for y. As example, let us see 400,000. We'll check out where is y here. We'll check out where is y. So 400 for y, you will multiply by 5. And 200, you will multiply by 3. And 170, you will multiply by 1. Then you will add all of them together. You will add all of them together. See, same thing, same idea. Here the y 400 by 5, 200 by 3, 170 by 1. Then you will add them. Then the point of y will be 3.6. Let me do it on the board and it will be clear for you guys when we show it on the board here. Okay. Again, this example, this man is having 3 points, 3 warehouses, and he wants to replace them with only one warehouse which will serve more, and for him to save money, and it will be better for his clients as well. So he has, let us see the example. I will go to the example. Yeah, he has the first location is here. This location is giving $400,000, and the x is 1 and the y is 5. 1 and 5. What is 1 and 5? This is the x, and this is y. So the point 1 and 5 here. Okay. The other one is down here. The other location, let's make it like this so it's not x, so it won't appear like it's x. 200,000, 200,000, okay, 200,000, and the points are 4.5 and 3. The points are 4.5 and 3. The third point is 170,000, 170,000, where he has 0.4 and 1. 0.4, x is 4 and y is 1. So 400, whereas x is 1 and y is 5. 200,000, whereas x is 4 and y is 5.3. 170,000, whereas x is 4 and y is 1. And he wants to locate, to remove all these three and put instead of one of them that it might be like intermediate between them. And we want to get the points where the x, what we will do is to calculate, we will calculate prospective x and y for the new location. We will calculate x and y for the new location. So what's happening here? I will get the new x. How I will get the new x? New x will equals, new x will equals, let's see, equal what? Every point here of the x's will be multiplied 400,000 by 1. 400,000, the x here is 1. 400,000 by 1. That's fine. 400,000 by 1 plus the other point is 200,000 by 4. 200,000 by 4 plus the third point is 170,000 by 4. 170,000 by 4. All this will be divided by the total numbers of 400,000 plus 200,000 plus 170,000. This will give me this number. Will give me 2.57. 2.57. So this will be the new x for the new site location will be when x is 2.57. This will be when x is 2.57. Okay. Let's go now for the point y. The same thing. What we did for x, we write it here now. New x is 2.57. This is x. How about y? Let us go to the example. Like we calculated x, we are going to calculate y. So how I will calculate y? The same root and the same stuff which we did just now. So to calculate y, we'll take the same numbers, but we will multiply this time in y. So 400,000 y perspective point will be 400,000 multiplied by 5 plus 200,000 multiplied by 3 plus 170,000 multiplied by 1, but all this divided by same like we did there, 400,000 plus 200,000 plus 170,000. That will come to for point y 3.6, 3.6, 3.6. Then prospective y will be 3.6. Here we go. Then y equals 3.6. Okay, okay, dokie. I have now x2 equals 2.57 and y equals. So it will be on, if I have a grid, and I draw it, it will be for x 2.57 and y 3.6. It will be almost here. Okay, and the point will be 2.57, 2.57, and 3.6. And that's how the final solution for this point. Let's see. Yeah, here it is. Let me share the screen back. Okay. So like you see here, 400,000 by 1. Because here is the locations. 400,000 by 1 plus 200,000 by 4.5 plus. So each amount of this will be multiplied once in the x's, once in the x number, 1 and 4.5 and 4, and once it will be multiplied for the y, 5 and 3 and 1. So each number will be x alone and y alone. Then what you will get is the numbers of x, the points, the location of x and y. So x will be on the point 2.57 like I showed you, and y will be 3.6.